Hello, everybody. How are you? How are you doing? It's me, the pioneer in methods, the Tunisian researcher in the field of solving nth degree from equation and solving nth degree general equation. So, let's see. First of all, I should check if I'm live or not. So, we are going first. I'm going to check my channel first. Okay, my channel is this one. Yes, okay, I'm live now. Okay, so my kids, we thought that it's me, Mourad Sultan Ezouidi, the pioneers in methods. Today we are going to solve 2 to the power 10, okay? I'm going to solve 2 to the power 10, and it's an occasion for you to start working on this kind of uh, subjects, okay? It's very hard, okay? This message is addressing to professors and colleagues, mathematical teacher, and for learners also, okay, like students. You are welcome, my kids, to enjoy your lecture of Mr. Mourad Sultan Ezouidi, and we will solve this problem to the power 10. Okay, this is it's in fact an extension of 10 to the power 9, okay, and we extend it. So the last term you see that is going to be equal to 0 means that we extend this from a ninth degree polynomial equation. Okay, and we'll start solving this 2 to the power 10. Okay, so prepare yourself, my kids. Okay, as pioneers in method, Mr. Mourad Sultan Ezouidi is now, let's say, live with you to let you learn new methods, new, and to let you see new theorem of me that leads you to get your exact roots of this 10th degree from equation. Okay, and the roots, they are very, very uh, let's say the roots are sorted in a manner where there is no error estimation. Okay, so prepare yourself. I will give you 1 minute to prepare yourself, my kids. This is the component to the power 10 is in front of you. Eyes, prepare your calculators and papers and start now working this component to the power 10. Okay, so I'm going to start now, my kids. Okay, so this is our problem to the power 10, okay? And I'm going to let you know how can you work with this 10th degree from the equation. Are you ready? Okay, I will first see this one. I already make, okay, this is my screen. This is how it comes here. Now, no need. Okay, this is the problem that I already want you to solve using, of course, the discrete formula of Mr. Mourad Sultan Ezouidi, okay, which is this. This is the problem to the power 10 matrix, okay, is that take a rest and be ready to join your innovation and discovery for solving 10th degree formula equations using the discrete formula of Mr. Mourad Sultan Ezouidi, and enjoy my colleagues, professors, and students your lecture. Okay, so let's work step by step up to till we reach, let's say, the new 10 degree from equation, and then we are going to make your last conclusion and solve out, let's say, the roots. Okay, the roots in fact now is in front of you. I already, let's say, summarized and wrote the roots here. Okay, now we start, my kids. I will tell this one. So here we have our function to the power 10. So P of x equal x raised to the power 10 minus 10 x raised to the power 9 plus 45 x raised to the power 8 minus 120 x raised to the power 7 plus 210 x raised to the power 6 minus 200 x raised to the power 5 minus 50 x raised to the power 4 plus 400 x cubed minus 475 x raised to the power 2 plus 250 times x plus 0. Means that the last term here is going to be 0. Means that this polynomial to the power 10, in fact, has been derived from a ninth degree polynomial equation by extension. Means we extend a ninth degree polynomial equation to get a 10th degree polynomial equation. So therefore, my standard form of writing, let's say, this polynomial is that p of x equal x raised to the power 10 minus L0 of ODQ x raised to the power 9 plus L1 of ODQ x raised to the power 8 minus L2 of ODQ x raised to the power 7 plus L3 of ODQ x raised to the power 6 minus L4 of ODQ x raised to the power 5 plus L4 of ODQ x raised to the power 4 minus L6 of ODQ x cubed plus L7 of ODQ x raised to the power 2 minus L8 of ODQ x raised to the power 1 plus L9 of ODQ equals 0. This is your handsome template from equation has to be written as the following. Now, as you can see, this is in fact is 1 to the power 10. I'm looking for the 10th new degree from the equation that has been that will be derived from my original 10th degree from the equation. Okay, means I'm going to find my new 10th degree coefficient from the equation. I will find the new coefficient of this one using the theorem of Mr. Mourad Sultan Ezouidi, and let's work this step by step. First of all, here, my kids, I'm going to apply my theorem. I will apply the theorem. The theorem is that, or the formula is that, S subscript k minus 1 over r equals the sum from 0 to k, combination n minus r, choose k minus r, and raised to the power r. The two parentheses negative 0 for the q raised to the power k minus r times lr minus 1 for the q. Okay, this is the formula of Mr. Mourad Sultan Ezouidi. It's called discrete formula. Because this discrete formula in fact is a kind of coefficient. It will give you the coefficient of your new 10th degree from the equation. For that, I substitute k equals 0 in my discrete formula. I will obtain that s minus 1 over the r equal combination and choose 1 minus 1, which is 0. So this one by convention is 1. Also, L minus 1 over the q also it will be equal combination n minus 1 choose 0, which is 1. Okay? Means that if the first coefficient of the x term with the highest power 10 is different to 1, you should divide all the coefficients by the first term, and then you are going to get to write your new standard form, your new polynomial standard form. Okay, polynomial equation standard form. Okay, now I will continue. I will try to apply this. I'm going to put k equal 1 in the discrete formula of Mr. Mourad Sultan Ezouidi. I will obtain a 0 for the r equal combination 10 to 1 times 10 plus 10 times 10, which is negative 100 plus 100 equals 0. You see the last term now is 0, okay, because we started from this one, okay, because you can see that the last term of my polynomial to the power 10 is 0, okay. Okay, now my kids, we continue. We told that 0 equals 0. Now I'm going to let k equal 2 in the discrete formula of Mr. Mourad Sultan Ezouidi, and I'm going to focus on the last general formula. After writing it in its simplest form, it will be negative combination 1 choose 1 times combination choose 2 times L0 of O the q squared plus L squared times L1 for q. Just this is a simplification, as simplification learns, and substitution. We just make S1 equal. This is my own calculator. There is no calculator, this one, okay. I will write what exactly, my kids? I will write negative, this is negative. 10 choose 2 is 45. Negative 45 multiplied by 1000, multiplied by 100, okay. Plus 45 multiplied by 100. This one, my kids, will give you exactly an half. This is meaning the S1 is equal to 0. Okay. Now I'm looking for my kids and my colleagues and my professors. I'm looking for the third coefficient of my new 10 degree from equation. To find the third coefficient of your from my third degree polynomial equation, you should substitute k equal 3 in the discrete formula of me, and then write it in its simplest form and make your own substitution. So this is the formula. I will use mine. So I subscript k minus 1 upon r equal the sum from 0 to k combination n minus r, which is k minus r, and raised to the power r between parentheses negative 0.2 raised to the power k minus r times l r minus 1 upon it. This one, after simplifying this expression, I will just obtain, I will write this as that combination 1, 2 choose 1, actually this one, sorry. I will make a combination 2, in fact, is combination 1 choose 2. Okay, 1 choose 2. This is 2, go up is 1. Okay, so this is the formula. This formula is has been generalized for any degree, for any nth degree polynomial equation. Okay, now I will make my own calculation. I will make substitution. It will be S2 equal combination 2 choose 1 times combination n choose 3 times L0 raised to the power 3. The n here is 10. Okay, L0 in fact is equal to 10. Then minus combination n minus 2 choose 1 n squared L0 raised to the power 1 times L1 upon 2 plus n cubed times L2. You see this is L0, this is L1, this is L2. I will just stop at the coefficient of L2. Then I will make calculation. Okay, this is my own calculation. I will try to figure out the value of this discriminant. I will just write 2 times what, Mr. Mourad? Times combination 10 choose 2. This is 10 choose 1. This is 10 choose 2. This is 10 choose 2. Means 120. You see 10 raised to the power 3, no need to do it now. Okay? Because all of them have a common factor, 10 cubed. 10 cubed. Okay, minus 8. Minus 8 times 45. Times 45. Okay, plus 120. Plus 120. Multiply by 10 cubed, no change. Okay, it will be 0. Therefore, S2 now is going to be 0. We'll proceed like that, my learners, to find the, let's say, the 11th coefficient of my new nth degree polynomial equation. So just now I'm focusing on S3. To get S3, my kids, it's clear that we will use this theorem, okay, S subscript k minus 1 for the r equal the sum from 0 to k, combination n minus r plus k minus r, n raised to the power r between parentheses negative 0.2 raised to the power k minus r times l r minus 1. This one when k equals 0, and after simplifying your own calculation and write this in its lowest term, I will just focus on the last one, which is S3 equal negative combination 3 choose 1 times combination n choose 4 times L0 raised to the power 4 plus combination n minus 3 choose 2 n squared L0 squared times L1 minus combination n minus 3 choose 1 n cubed times L0 raised to the power 1 times L2 plus n raised to the power 4 times L2. This formula will give you, in fact, the fourth degree polynomial equation. Okay? Now, I'm going to continue. So, I will focus, of course, here. This is L0, L9 is equal to 0, not 30. Now, I'm going to calculate. This one, you can see negative 3 choose 1. Okay, I will use the calculator. So, raise everything. We have negative 3 times 10 choose 4. 10 choose 4. This is 10 choose 1, 10 choose 2, 10 choose 3, 10 choose 4. Meaning multiplied by 210. You see 10 raised to the power 4 here. And this is 10 squared by 10 squared is 10 raised to the power 4. Then take 10 cubed by 10 is 10 raised to the power 4. 10 raised to the power 4. So it's a common factor. No need to write it now. Okay? If the answer is different to 0, multiply and use it. If not, no need, because any value number different to 0 multiplied by 0 is 0. Okay? So here I will make a plus combination 8 choose 2, the kids. Where is 8 choose 2? It's 28 times 28. okay, plus 28. Multiply by 45. Multiply by 45. Then minus 10, minus 7, sorry. Minus 7 multiplied by 140. Okay. Then plus 210. Plus 210. This, my kids, is equal to 0. Therefore, we calculate S3. It remains S4 and S5 and S6 and S7 and S8. Then S9 and we stop. Okay? Because we told that K ranges from minus 1 to n minus 1. The n is 10. 10 minus 1 is 9, meaning from minus 1 to 10. Okay? So I will continue. I'm looking now my kids S4. To get S4, just make substitution in the discriminant formula of Mr. Mourad Sultan Ezouidi by k equals 5. Okay, in this discriminant formula or in this theorem. I will write S4 equal combination from 0 to 5 times combination, the sum of course, sum from 0 to 5, combination n minus r to 5 minus r, and raised to the power r between parentheses 0 to the 0 of order 5 minus of order q to the power 5 minus r times and r minus 1. This one, it will be negative combination n choose 5, L0 for the q raised to the power 5 plus n combination n minus 1 choose 4, L0 of all the q raised to the power 4 times L0 of all the q. Okay, you see this one? It's a common function. I took here in the kids, okay, and the difference of this will give you exactly combination 4 choose 1 times combination n choose 5, L0 for q raised to the power 5. The rest, this, when r equal uh, 2 and 3 and 4 and 5, they are written as they are, not changed. Okay. So I will use the last formula, okay. Then I'm going to use the coefficient of my original 10-degree formula equation. So I will just now make my own calculation. I'll just use this one. It will be equal in fact. So we have 4 times 10 choose 5 means 4 multiplied by 10 choose 5, 10 choose 5, 1, 2, 3, 4, 5, 250, 252 multiplied by 252. 10 raised to the power 5, it's a common factor. 10 raised to the power 5, it's a common factor. 10 raised to the power 5, it's a common factor, and here it's a common factor. So I will ignore this step. Means I'm going to multiply by the coefficient of my original 10-degree equation only. Then the answer, or the output, should be multiplied by 10 raised to the power 5. If it is 0, no need. If it is different to 0, so we should do it. Okay, let's do. We call the negative combination 8 choose 3, because this is 8 choose 3. There is 8, 1, 2, 3, 56. Means 56 minus 56 times 45. Minus 45. Okay. Then plus 7 choose 2. Plus 7 choose 2 is 21. Plus 21 multiplied by 120. Multiplied by 120. Minus 6 times minus 6 multiplied by 210. By 210. Then plus 200. Plus 200 plus 200. This one is equal to, in fact, negative 52. Negative 52 should be now multiplied by 10 raised to the power 5. It will be equal negative 5,200,000. This one, I can write it as that. I will use this one because it's a common factor we told from the beginning. What is it? Okay. Equal negative 52 only multiply by what, my kids? Multiply by 10 raised to the power 5. Okay, this is the last answer. Here, guys, I wrote it in extended form. I can write negative 5.2, 10 raised to the power 6. Okay, I will write it down. Now we calculate, let's say, S4, we will say that is negative 52, 10 raised to the power 5. Okay. I'm here continuing to find S5. To find S5, just put K equals 6 in the discrete formula of Mr. Mourad Sultan Ezouidi, and then you will come to write it in its simplest form after, let's say, showing that L0 of ODQ raised to the power 6 is a common factor. Here, it's a common factor. Therefore, you make L0 of O the or the Q raised to the power 6 times combination n to 6 minus n times combination n minus 1 to 5. The difference between this one is equal to negative combination 5 choose 1 times, sorry, negative combination 5 choose 1 times combination n to 6. Okay? And 0 for 0 raised to the power 6 plus combination n minus 4 choose 4 n raised to the power 2 and 0 for 2 raised to the power 4 times n1 for 2 minus combination n minus 3 choose 3 times n cubed times n0 for the 2 raised to the power 3 times n cubed for the plus combination n minus 4 choose 2 times n raised to the power 4 times n0 for the 2 squared times n cubed for the mine is combination n minus 5 to 1 n raised to the power 5 times n raised to the power 1 times n power 2. I will now use this one. I will make my own substitution. N is 10, L0 it's clear that it's 10. The L1 is 45, the L2 is 120, the L3 is 210, and then I'm going to start at the coefficient of my fifth coefficient of my new original 30-degree combinatorial, which is equal to 200. Okay, substitution now learns, and I'm going to calculate this. Okay, you can see this. There is a common factor which is 10 raised to the power what? In fact, to the power 6. This is 10 squared by 10 raised to the power 4 is 10 raised to the power 6. 10 cubed by 10 cubed is 10 raised to the power 6. 10 raised to the power 4 times 10 squared is 10 raised to the power 6. So it's clear that in fact is 10 raised to the power 6 is a common factor. Then I'm going to ignore this stuff. Okay? I will write negative 5 times what, my kids? Times 10 to 6. 10, which is 1, 2, 3, 4, 5, 6. Means 210. Multiply by 210. Okay. Plus 8 choose 4. Plus 8 choose 4. 1, 2, 3 means 70. Plus 70. Multiply by 45. Multiply by 45. Minus 7 choose 3. 7 choose 3, my kids. 1, 2, 3 is 35. Multiply by 140. Multiply by 120. Then plus 6 choose 2. This is 6 choose 1. This is 6 choose 2. Okay? Means my kids plus 15 or minus 15. Plus 15. Plus 15 times 210 times 210 minus 5 times 200 times 200 plus or negative 50. Negative 50. This one, if it is different to 0, you should multiply it by 10 raised to the power 6. If it is 0, خلاص, no need. Okay, this one, my kids, is going to be equal to 0. Therefore, I calculate now S5. It remains S7 and S8 and S9. So we reach to continue to solve this to the power 10. So of course this is a 0. Okay, the last term we called from the beginning is going to be equal to 0. I'll check. Of course this one is going to be equal to 0. Okay, because the last term is 0. Okay. Okay. Now we continue. We'll obtain this. Okay. So found now I'm going to find S6. To find S6, my kids, go back to the theorem of Mr. Mourad Sultan Ezouidi, known or written or named as discrete formula of Mourad Sultan Ezouidi, and substitute k equals 7, we will obtain S7 minus 1 will give you S6. The sum from 0 to k will be the sum from 0 to 7. Combination n minus r choose k minus r will be written as combination n minus r choose 7 minus r. N raised to the power r is the same. minus L0 for the q raised to the power k minus r. It will be negative L0 for the q raised to the power 7 minus r times what? Lr minus 1 for the q, and here also is Lr minus 1 for the q. After making the expansion of this sum, I will obtain, after of course collecting like terms and putting it common factor. Okay, put up the brackets, then opening the brackets if we have something in common. You see here L0 of O to Q raised to the power 7, and this L0 of O to Q raised to the power 6 times L0 of O to Q. This is also it's L0 of O to Q raised to the power 7. I will put it outside the brackets. Okay. After that, so this one has to be equal to combination 6 choose 1 times combination n choose 7 times L0 of O raised to the power 7 minus combination n minus 2 choose 5 n squared L0 of O raised to the power 5 times L1 of O plus combination n minus r3 choose 4 n cubed times L0 of O raised to the power 4 times L2 of O minus combination n minus 4 choose 3 n raised to the power 4 times L0 to the power 3 times L3 of 42 plus combination n minus 5 choose 2 n raised to the power 5 times L0 raised to the power 1 times L4 of 42 minus combination n minus 6 choose 1 n raised to the power 6 times L0 raised to the power 1 times L4 of 42 plus n raised to the power 7 times L6 of 42. I will use my own calculator like this here. Okay. I will ignore 10 raised to the power 7 because it's a common factor. 10 raised to the power 7 here. And here you can see 10 raised to the power 6 times 10 raised to the power 1 is 10 raised to the power 7. Also, 10 raised to the power 5 times 10 squared is 10 raised to the power 7. Of course, this one is also can be written as 10 raised to the power 7. 10 cubed times 10 raised to the power 4 is 10 raised to the power 7. Okay, you can see this one also. 10 squared times 10 raised to the power 5 is 10 raised to the power 7. And this one 10 raised to the power 7. So it's clear, my professors and colleagues, that 10 raised to the power 7 is in fact it's a common factor of all the terms. So I will ignore this 10 raised to the power 7, then I'm going to do my own calculation to simplify this formula. Okay, so we have 6 times what? Times my kids times 10 choose 7. This is 10 choose 1, 10 choose 2, 10 choose 3, 10 choose 4, 10 choose for me 1, 2, 3, 4, 5, 6, 7 means 120 times 120 minus 8 choose 5. Okay, I will put this here. 8 choose 5. Okay, 8 choose 5. 1, 2, 3, 4, 5 minus 56. Minus 56 times 45 times 45. Then plus 7 choose 4. This is 1, 2, 3, 4 minus plus 35 times 120. 1, 2, 0. Minus 6 choose 3 is 20. 1, 2, 3 means minus 20. Multiply by 210. Okay, by 210. Then plus 10, 5 choose 2 is 10. Plus 10 times 200 times 2 double 0. Minus 4 times negative 50 means plus 200. Plus 200. Because minus multiplied by minus 4 to 50, 200. Minus 400. Minus 400. Minus 400. So this one is a noun. No need to multiply this by 10 raised to the power 7. Okay, so it's easy. Okay, we continue. Now I'm looking for S8, then S9, and we finish this. Okay, to find now S7, my kids, we should put K equal 8 in the decimal formula of Mr. Mourad Sultan Ezouidi, that is colored with green, okay, by the color. So I will just write this as 7 over R equal the sum from 0 to 8. Combination n minus r is 8 minus r, n raised to the power r, the two parentheses 0 to the 0 for 0 raised to the power 8 minus r times l r minus 1 equal to 0. When r equals 0, it will be written as combination n choose 8, and 0.2 raised to the power 8. When n equals 1, it will be negative combination n minus 1 choose 7, and 0.2 raised to the power 7 times n 0.2. When n r equals 2, it will be plus combination n minus 2 choose 6, n squared, and 0.2 raised to the power 6 times 1.2. When r equals 3, it will be negative because of number, and this is when it is a negative number raised to the power another number, that will be negative, it will give you negative sign, minus combination and minus 3 is 5, and cube, 0 to 42 raised to the power 5 times 4.2. When n r equals 46, it will be plus, because 4 is even number, minus 1 raised to the power even number is positive, combination n minus 4 to 12, and raised to the power 4 times and 0.2 raised to the power 4 times and 0.2 minus, well now r equals 5, will be combination n choose 5, n minus 5 to 3, and raised to the power 5 times 0.2 raised to the power 3 times n4. When r equals 6, it will be positive, because minus 1 raised to the power 6 is positive. So it will be combination n minus 6 choose 2, n raised to the power 6 times n 0.2 squared times n 5.2 plus, when now r equals 7, it will be negative sign, negative combination n minus 7 choose 1, n raised to the power 7 times n 0.2 raised to the power 1 times n 6.2 plus n raised to the power 8 times n 7.2. You can see this one, a 0.2 raised to the power 8 and 0.2 raised to the power 7 times a 0.2, in fact, is and 0.2 raised to the power 7. I will put it outside the brackets. Then I will make the difference between combination n choose 8 and my n combination n minus 1 choose 7. This difference is written as negative 7 combination 7 choose 1 times combination n choose 8 times a 0.2 raised to the power. The rest had been written as r, because there is no common factor and there is no like terms to collect or to add or subtract. Okay, so I will focus now. I will focus on this formula and I will substitute, let's say, any term. So it will be as 7 equals negative combination 7 choose 1 times 10 to 8 and 0.2 raised to the power 8 plus combination 8 choose 6 and square root 0.2 raised to the power 6 times 1.2 minus combination 7 choose 5 and cube and 0.2 fifth times and 4.2 plus combination 6 choose 4, okay, because 10 minus 4 will be 6. N raised to the power 4 and 0.2 raised to the power 4 times L2 minus, we see n minus 5, 10 minus 5 will give you 5, so minus 5 choose 3. N raised to the power 5 times n 0.2 raised to the power 3 times L4. When n now equals 10, 10 minus 6 will be 4 choose 2. N to the power 6 times L 0.2 squared times L5 for the cube. When now 10 is equal to n, 10 minus 7 will be 3, 3 choose 1, n raised to the power 7, okay, and 0.2 raised to the power 1 times n6 for the 2 plus n raised to the power 8 times n7. I will use now my calculator and then I'm going to make substitution. I will obtain the value of a 7 equal to 0. You can do this, kids, but if you would like to do it, I will do it, no problem. Okay, so you see, negative 7 first, multiply by what? 10 choose 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8 means 45 times 45. Then plus 8 choose 6. 8 choose 6. This is 1, 2, 3, 4, 5, 6 means 28. Means plus 28. Okay, times 45, because the coefficient and 1 is 45, is equal to 45. Minus 7 choose 5. This is 1, 2, 3, 4, 5, means minus 21. Multiply by 120. Multiply by 120. Plus 4, 6 choose 4. This is 1, 2, 3, 4, means plus 50. Plus 50. Multiply by 210. multiplied by 210. Then minus 5 times 3 is 10, minus 10. Multiply by 200, multiply by 200. Then plus 4 times 2 is 6, plus 6. Times negative, okay, times negative 50. Negative 5 units. Close the parentheses, okay. Then you see minus 3 times negative 5 will be plus. Plus what? 1 2 double zero. Minus 475. Minus 475. 75. This is my kids video fact equal to 0. Okay. Now I will continue. I want S8. To find S8 matrix, it's clear, it's easy to do. Okay, this is the formula, of course. I will make, and give it, let's say, another color. Well, now it's not clear. Green, what do you think? Yellow is better. Yes. I will use this formula when k equal 9. I will substitute k equal 9 with this formula from Mourad Sultan Ezouidi, so that I can write it in its simplest form. Okay, like that. S8 for the R equal combination 8 to 1 times combination n to 9 for any n degree from equation. That's why here it's written times a 0.2 raised to the power 9 minus combination n raised to the 7 n squared and 0.2 raised to the power 7 times 1 plus combination n minus 2 to 6 n raised to the power 3 times a 0.2 raised to the power 6 times a 0.2 minus combination n minus 4 to 5 n raised to the power 4 times a 0.2 raised to the power 5 times a 3.2 plus combination n minus 5 to 4 times n raised to the power 5 times a 0.2 raised to the power 4. This is of course plus 0. Okay, minus combination n minus 6 to 3 n raised to the power 6 times n raised to the power 3 times L4 L5 42 plus combination n minus 7 to 3 n raised to the power 7 times L0 42 squared times L6 42 minus combination n minus 8 to 1 n raised to the power 8 times L0 42 to the power 1 times L6 42 plus n raised to the power 9 times L8 42. I will use this general formula, okay, for any n degree from equation will give you, let's say, the 10th coefficient, okay, of your new n degree from equation. I will use all these coefficients except L9, okay, because the last term in the formula is L8. I will use my calculation. This is calculator. Now I will ignore everything. You can see here kids 10 raised to the power 9, in fact, is a common factor. It's a common factor. Okay. 10 5 times 10 4, 10 9, 10 raised to the power 1 times 10 raised to the power 8 is 10 raised to the power 9, 10 raised to the power 7 times 10 squared is 10 raised to the power 9. Also 10 raised to the power 6 times 10 raised to the power 2 is 10 raised to the power 9. That's why I will ignore this 10 raised to the power 9 till to simplify the calculation for you first. Okay, I'll just now calculate. Will be negative 8, 8 times 9, then minus 8 times 45, times 45, then plus 7 times 120.20, then minus 6 times 210, then plus 5 times 200 times 200. Now minus multiplied by minus 44 to 50 plus 200. Plus 200. Okay. Minus 3 multiplied by 400 means minus 1200. Plus 2 multiplied by 4 700 475 minus 950 plus 950. Okay. Uh-huh. Minus 250 minus 250. This one, in fact, is equal to minus 8. Okay. Let's check again, Mr. Noah. Okay. We have negative 8 multiplied. Sorry, yes. I made 8 multiplied by 9. Now, combination 8 choose 1 is 8 times combination 10 choose 9 is 10. Okay. That's 8 multiplied by 10 minus 8 multiplied by 45 plus 7, yes, plus 7 multiplied by 120, 120, minus 6 multiplied by 210, minus 6 multiplied by 210, plus 5 multiplied by 200 means 1000, plus 1000, then 4 multiplied by 50 plus 200, then minus 1200 because 3 multiplied by negative 400 minus plus 950y simply because minus 2 multiplied by minus 475 is 950 minus by minus 250 plus term is minus 250. This one is equal to 0. Okay. Now, my colleagues, we reach, let's say, the value of S. Course, this is S8. Okay, this is S8, not S7. This one is S8. Okay, good one. Okay, because we use this formula, S8. Okay, 7 we calculated before. Now I'm going to come to the last step, which is K equal 10. Okay, good man, Mr. Mourad Sultan Ezouidi, the Canadian researcher. Keep it up and don't give up. Okay, we are here to explain to your professors and teachers, mathematical teacher, and you learn how can we solve 2 to the power of 10. Okay, okay. Now it remains the last step. Then we will see how it works. So now, my kids, to find the S9, you should go back to the decimal formula of Mourad Sultan Ezouidi, and you should substitute, let's say, k equal 10. Okay, means I will apply this theorem. S subscript k minus 1 equal the sum from 0 to the sum from 0 to k, combination n minus r, choose k minus r, n raised to the power r, filter everything into the 0 for dt, raised to the power k minus r times and r minus 1 for dt. I will make my own substitution and my own calculation, and I will I will figure out, sorry, N0 for dt raised to the power 9 as a factor, then I will make the difference between combination n choose 10 and n combination n minus 1 choose 9. This one is in fact equal combination 9 choose 1 times combination n choose 10. This is according to Sultan Ezouidi and according to his method. Okay, times at 0 for 2 to the power 10. The rest terms have to be written as they are, not changed. Okay, so it will be S9 equal minus y minus because the subscript 9 is off. If it is even, it's positive. Okay, so it will be negative combination of 9 choose 1 times combination n choose 10 L0 for the 2 raised to the power 10 plus combination n minus 2 choose 3 n raised to the power 2 times L0 for the 2 raised to the power 8 times 1 for minus combination n minus 3 choose 7 times n cubed times L0 for the 2 raised to the power 7 times L2 for the cube plus combination n minus 4 choose 6 n raised to the power 4 times L0 for the 2 raised to the power 6 times L3 for the 2 minus combination n minus 5 choose 5 n raised to the power 5 L0 for the 2 raised to the power 5 times L4 for the 2 plus combination n minus 6 choose 4 n raised to the power 6 times L0 for the 2 raised to the power 4 times L5 for the 2 minus Combination n minus 7 should be n raised to the power 7 times a 0.2 raised to the power 3 times a 6.2 plus combination n minus 8 choose 2 times n raised to the power 8 times a 0.2 raised to the power 2 times a 0.2 sorry times a 6.2 minus combination n minus 9 choose 1 n raised to the power 9 a 0.2 raised to the power 1 times a 6 put at 6 here this one. So this is 5, this is 6, this is 7. Okay, this is 7, this is 8, and the last one is minus. Okay, now we should be careful to this kind of theorems. So we call the minus combination n minus 9 choose 1, n raised to the power 9, at 0.2 raised to the power 1 times n 8 42 plus n raised to the power 10 times n 9 42. This you see as 9. This plus formula, this one, is the general formula to get, let's say, uh, let's say, the 11th coefficient of your 10th degree equation. Okay, so it's very important. You cannot find, let's say, the coefficient of any nth degree equation without this formula, without the discrete formula or this formula. Okay, okay. Now, my kids, I'm going to make my own calculation. You see the last formula, I will give it, let's say, another color. Maybe now it will be different. I will make a green color. So it's better now, green color no need. Back, do it like, yes, right, yes. Blue, no. This one, no. This, okay, that's good. Okay, that's good. Good color. Great color. Okay. Means now why we give it, let's say, a gray color to tell that if you reach these steps and if you practice this theorem of mine, okay, you are good learner and good professor and good students. Okay, so now I make my own calculation. Okay, you see the last term here is 0. I will substitute the last term here. Last be the same challenge for the coefficient. I will now use my calculation. It will be my case, okay, S9. This is S9. This is S9 if I use my kids. This is 9. Sorry. Okay, we called minus this one. Okay, 9. Okay, fine. Now we take like this. Okay, we have 9. Well, this is of course 10 like this. You see this one? This one is 10 choose 10. The formula is the formula negative combination 9 choose 1 times combination n choose 10. And n is 10. Means 10 choose 10 is 1. So this one should be replaced with 10. Or I will ignore this step. I will just make, where is it? Here, down. This one, huh? I will change this with, yes, where is it? Yes. This is with 10. Okay. 10 choose 10. 10 choose 10 is 1. This is according to the formula, of course. Don't try to write anything. So I will use my calculator. I will go back. I will go down. So this is basically like that. You can calculate it. It will be negative 9. You see 10 raised to the power 10 is common factor in all the terms. Okay? All the terms. So no need to write it now. Okay? Simplify the calculation. So for you. Plus 45 plus 45 minus 120 plus 210 minus 200 minus 50 plus 400 minus 475 plus 250. This one is equal to, my kids, equal to 51. So 51. Okay. Go back and check it out. Okay. The formula is negative conditional minus 1 times for the factor. Okay. So it will be minus 9 times, okay, times, okay, plus 45 plus 45 minus 120, because this is minus minus plus minus plus minus plus minus plus minus plus. Okay, correct. So we reach, let's say, negative 120 plus 210 minus 200 minus minus 200. Okay, plus, okay, negative 50 minus 50. Okay, then minus multiplied by minus is 40 plus 400. Okay, plus 400 minus by minus. Then plus, there is negative 475. Then minus by minus is 40 plus 250. 250, the coefficient this one. Okay, this one is equal to 51. Okay, so it will be 51 multiplied by what? 12. 51, this is 51, this is 12. Okay, I'll check my calculator now. I will check my calculator. I will calculate this again and do your calculation and check if it is 12 or 15. Okay, calculator. Okay, so we will repeat negative 9 plus 45 minus 130 plus 210 minus 200 minus 50 plus 400 minus 475. Okay, plus 250. Yes, 51. Correct. 51. Okay. Now, how comes here, my kids? I will 51, it will give, in fact, is equal to 51. This one is equal, in fact, to, okay, okay, I will write in standard form. Okay. So I will come here. I will, this is 51. 50, this is what? Okay, 51, 10 into the power 10. It's, okay, all the s subscript k minus 1 are equal to 0 except s minus 1 for q and s4 for the r and s9. Okay, I will write this as that. Okay, so I will make it, excuse me, I will make it like that. So it will be, this is 51, of course. So this one is can be written as, we told p of x equal x into the power 10 minus s0 for the r x9 plus s1 for the r x8 minus s4 for the r x7 plus s3 for the r x6 minus s4 of all the r x to the power 5 plus s5 for the r x4 minus s6 for the r x2 plus s7 of all the r x2 minus s8 for the r times x plus s9 for the we told all the s subscript are equal to 0 except s4 and s9 and s minus 1, which is the coefficient of the external raised to the power 10. Okay, but it's 51, so we need no need to write it. Therefore, this one is equal to 1. Okay, I will put y equal x into the power 5. P of x into the power 5 is equal to x into the power 5 all raised to the power 2 minus s4 over r x raised to the power 5 raised to the power 1 plus s9 over r. Therefore, I will obtain second degree polynomial equation in terms of what? P of y equal y squared minus s4 y plus s9 equals 0. I will use the decimal formula of u. S1 of order q dash equal negative s4 of order r squared plus 4 times s9 of order r. This comes from the decimal formula of Mr. Mourad Sultan Ezouidi. And you will see this is the opposite to the quadratic formula that you already know. Okay? So it will be negative. This is negative sign. This is negative equal. Negative 5,200,000 squared plus 4 times 51. This is 51. Okay. So I will use my calculator methods. I will just write multiply by 10 raised to the power 10. Okay. Then, okay, minus in parentheses. Okay, minus in parentheses like that. 52 multiplied by 10 raised to the power 5 all squared. Okay, I close this one and make square. This one is equal to what? Equal to negative, okay, to negative 2,653 multiplied by 10 to the power, okay, I will write this as negative 2653. 2653. Okay. It will be 53 somewhere. Is possible? Where am I writing it? Oh my god. Hmm. This is equal to 51, isn't it? Okay. 51 multiply. Multiply. 10 raised to the power. Okay, like that. Now what this is 26, 2,653. And 53. Okay, 5. Okay, this one it is negative, isn't it? So when you put a negative sign, this can formula you will feel positive. Oh, that's right. This is 8, and this one. Okay. Now I'll check again. So I'll make, okay, I'll check again about the answer. We form negative 5, 2, 1, 2, 3, 4, 5 squared. Okay, multiply by minus 1. Multiply by minus 1. Okay, no problem. No. Wait. Okay, erase. We found negative, negative 5, 2, 7, 0, 0, squared. Multiply by negative 1 plus 4 times 51 minus 5, 1 multiply by 10 raised to the power 3. Okay, this one is equal. I'll check this calculation. Okay, okay. 2,108. I will take this and I will check again. Okay, I will write this first. This is equal. I will ignore this step. Then I will calculate again. All that. Okay. So this one, if it is correct, it will be 29. I will prepare first. 29. 2908. Then I raise this. Okay, 10 raised to the power 4. Okay, I will do the calculation internally again. So that we get, okay, we have my kids. First of all, I will make 552 multiplied by 10 raised to the power 5. Then I should square this number. This one is equal. Okay, square this one. Then multiply by, between parentheses, negative 1. Lower the parentheses is equal. Okay. Plus 4 times what? Times 51 multiplied by 10 raised to the power 3, like that. Okay. This one is equal to kids negative, you see? Negative 25. Okay. So this is calculated will give us, let's say, two different ranges. See? Okay. I will write it equal negative 25. Okay. Negative 2 5 double 0. Okay. Erase this one. 333. Okay. Yes. Mean is negative 25 double 0 10 raised to the power 10. Okay. I'll check my own calculator. Okay, I will do this again. So this is minus, therefore it will be positive. 2500 and we, okay, because this is S1 of 42 is negative. Therefore minus S1 of 42 is this. Why? Because when you are working with second degree from the equation, your new second degree from the equation will be written as x squared plus S1 of 42 equals 0. Therefore, x squared should be equal to negative s1 of 42. Okay? Okay, therefore, okay, means, I will explain this for you. I will explain this for you so that you understand. Okay, so let's see from where it comes. Therefore, I will now write, for example, p of x equal x squared plus s1, okay, minus s0. I will make minus s0 of order r times x plus s1 of order plus s1 of order. Of course, here I will change to dash equal. This is equal. Okay. You see this one? This new second degree from equation was obtained from the original second degree from equation. You see S1 is plus term. S0 always is 0. Therefore, I will obtain x squared plus S1 of 42 equals 0. Means x squared, of course, 2 dash, because I interfere with dash notation. Okay. So therefore, this is 0 because S0 is always 0 for any integral equation. So x squared equal minus, I will transfer this on the right hand side. It will be minus S1 of 42. That's why the x squared has to be equal to that. The S1 is that, okay? Here it's negative. When you transfer that, it will be positive. If it is positive, when you transfer it will be negative. This is depends on the value of S1 of 42 dash. It's called this. Okay. Now we'll calculate last calculation for you. Let's check now. If I will make now 52, 5,200,000 squared minus 4 times 51 multiplied by 10 raised to the power 10 should be equal to the same equal 2000. Okay, so it's correct. So now it will be 2,500 and 10 raised to the power 4. Okay, outcome is here, my kids. I will try to first of all okay to make this bigger for you so you can see. 14, 16, 18. Okay. So this one it's clear like that. Okay. Now it comes here. Okay. Now we'll simplify. Total 2,500. 10 raised. Okay. Now we'll try to appear 2,500. It's a number multiplied by 4. Okay. I will now appear this one. I will appear the 2. Then 2,500. Sorry. 2,500 because 10 raised, of course, 10 raised to the power 5 squared. Okay, So it will be 2500 divided by 4 to appear the two, because I'm going to simplify by 2. It will be 625 with me. So it will be 625. Where is it? So it will be here 625. 625. Okay. This is also root of 625 is what it is. You can simplify this, okay? So just like here, 625, which is in fact 25. Okay. Now you can see this one negative 52 times I make it times immediately I make 52 multiply by, okay, by 5, multiply by 5 raised to the power 5, then I will erase this 0, okay? Then this one of course becomes like that, equal 52. So 52 divided by 2 gives 56. Multiply by what? Multiply by 6 by uh, by 10 raised to the power 5 plus negative, because it is minus 10 multiplied by 625 raised to the power half. I will ignore this. I will make immediately, okay, 10 raised, this is multiply. I will insert the multiplication. I will make 25 simply because root of 625 is 25. Okay. Why? Because like that. I will make root of 0.5. 0.5. This one is equal to 25. Okay. To simplify the calculation for you. Of course, this is not 2 point, it's 26. Okay. Now I will continue. So this is y equal. Now I will write y is equal to S4. This is okay. We cancel this. Plus negative, plus negative, plus negative. Okay. Now my kids, I will put 10 raised to the power 5 as a common factor. So it will be plus 25 plus negative 25. Okay. Now let y equal x raised to the power 5 because we did it before. Okay. Now it comes here. I can simplify this, my kids. I can write it as if it is positive or negative. I will make like that. This one is equal 10 raised to the power 5. You see, if it is positive, it will be negative 1. See, minus 26 plus 25. It will be negative. First is going to be negative 1. Negative 10 raised to the power 5. Or, or it will be negative. It will be 25, 51. Negative 51. Negative 51. Okay. Negative 51 multiply by 10 raised to the power 5. Multiply by 10 raised to the power 5. Like that. Okay. These are the two possible roots. Okay. Turn it down. Now, we thought this is y equal this or that. Minus 26 plus 25 is minus 10 raised to the power, because I multiply this by 10 raised to the power. Then minus 26 minus 25 is equal to 51. Okay. Therefore, my previous, this one is equal to x5 is equal to 5. I will ignore this one and ignore. I will just ignore this. Ignore and I will make x5 equal negative 10 raised to the power 5. Okay. Or I'll put as it is first. It's better. Okay. There are down. Okay, I will solve this one first. We told that this is negative 25. Then we make all confusion. Okay, which is okay, negative, negative. equal, ignore this step. So we call x5, this is y equal x5 of course. And to this here, y equal x5 equal means that means that this is implies that x5 okay equal this. Therefore means x5 equal minus 10 to the power 5 or this one. Okay, just like x5 equal either minus 10 raised to the power 5, okay, because minus 26 plus 25. Or, of course, I will write this one, or, okay, equal negative, okay, equal negative 51 times this one we have, times, okay, times 10 raised to the power 5. Therefore, now you can see I will take this one here. I'll take the first. Okay. So this one equal. I will make here. Okay, for insert let's say symbol. I will make between parentheses. This is okay. Negative we take okay. Lower the parentheses. Raised to the power 1 over 1 divided by 5. Okay. Exponential 2k I5. Then the negative side here comes here. Okay, so I'll ignore this negative sign. Because this one I will write as that matrix. I'll explain this for you. This is y equal, and so here are equal. But here I will just ignore the last term. Okay, and the 1, the 5 I will change with 1. But to appear the fraction, not only. Okay, this is also 1, because x is to the power 5. Okay, ignore this one for coming from the negative side. Now we see the negative side, I will add exponential I5. Therefore it will become 2k plus 1 I5 over 1. So I cancel this one. Good one. Then, okay. We did this. Now we move to the next one. Okay, so just like this and that. I will take this. I will take this. So it will be the only the first one. I need to the second. Okay. It will be. Okay. It will be negative 51. Negative 51. Okay. 10 raised to the power 10 raised to the power 5. Let's take all of this. Okay. Then I will erase this one. Shift. No. Okay. 1 over 5. Now divide by 5. Okay. You see, this is of course 2k plus 2k only. The minus, you see there is negative sign. The negative sign will come as we written as exponential. I would like to make this possible. This minus, or I will do it like that. There's no problem. I will keep everything equal. And minus I will change with what? With exponential I5. Exponential times exponential I5 because it's negative. Exponential I5. I times 5. Okay. Then I should divide this by 5. Okay. You see, when you divide this by 5, this one, of course, this one has to be equal to. I will first continue doing this. Okay, until the first one. And therefore, okay. You see, 10 raised to the power 5, raised to the power 1, but it will be only 10. So I will now, okay, I will just write 10. Then, the next, also this one is equal to, okay, equal, enter, equal what? So 10 raised to the power 5 raised to the power 5 will be 10. I will write it here 10. Okay, this one I'm now going to place 51. Let's write 51. Exponential I5 divided by 5, it will be, I will add here just plus 1. Plus 1. Okay, and then I'm going to fix this one. Okay, so now I got my xx. The xx is that. The first term is that. Okay, okay, yeah, as it is. Okay, now I'm going to come here to change. So L0 plus xk. L0 is 10 plus xk, then I'm going to raise the rest. Okay, divide by 10. Of course, this one has to be written as 10 plus 10 over 10. So it will be 1, okay, plus, this is plus what? This is, it will be, my kids, only 10. Only, yes, 10 divided by 10 is 1, because 10 raised to the power 5 raised to the power 1/5, here 10. 10 divided by 10 is 1. So just write, just raise this one. Okay. The next, now I will use this one to continue the next step roots. So it will be plus, this is minus, okay, okay. You see, 10 divided by 10 is 1. 51 multiplied by 10 raised to the power of, okay, because this one, I will take this plus 2. Okay, ignore this because the last will simplify. Yes. Okay, no problem. I'll take it again. Okay. Okay. Yes. Mm, okay. I will ignore this one. I will take this. Okay. I'll take this again. Copy. Go down. Rename it. Okay. Come here. In code I will take 10 times 51 raised to the power 5 times exponential k plus 1 over 5 times I count. I will put it here. Math object 10. Okay. Okay. Yes. Okay. We have, I will write 10 times 10 times. Okay, okay, equation. Okay. The 51 raised to the power 51, 5 what? Raised to the power 1 divided by 5. Okay. And then, of course, we multiply. Okay, this is here multiply. Exponential. exponential e raised to the power e raised to the power 2k plus 1 2k plus 1 times I5 times I5 divided by 5. Okay, I finish it now. Divide by 5. Divide by 2. You see, 10 divided by 10 gives you it remains only 51 explanation plus 10 extra. Okay, plus. Okay, you see, now my kids, when k equal 1, when k equal 2, it will be exponential of 2 times 2 plus 1, means 5. Divided by 5 is 1. Exponential of I5 is 0. 1 minus, exponential of I5 is minus 1. 1 minus 1 is 0. So the first root, in fact, is equal to 0. Okay? Because we extend the ninth degree equation to 10th degree equation, means the x equal 0. So let's check it here. Okay? So these are the roots of my polynomial to the power 10. Okay? And tomorrow I will go back to this for the extension and I will solve the ninth Newton equation. Then I will go to use these roots and make my own conclusion. Okay? This is exactly what we need. Thank you and goodbye. This is Mr. Mourad Sultan Ezouidi. Okay? And I wish that I got the point. How can you solve this one to the power 10? Now I will look at my kids. I will go back to Mathways solver windows and you can solve this kind of question in front of you. Okay, so I will take the proof to the power 10, then I'm going, they will just give me the single rule that is equal to 0. Okay, let's see. Yeah, Rex before. I will take this, copy and copy. Now I will go back to the Mathways to see that Mr. Mourad really is doing his best. Okay, let's go. Okay. Okay. So it just comes here. Here, for example, I will make Mathways Windows Microsoft. Microsoft. Hi Microsoft. Take my phone Microsoft. File name. Let's use this. Okay, this is the phone. Go. It's here x equals 0 only. You see? He evaluate x equals 0 and he can't, let's say, find the value. Let's see, Mr. Marshall. Really okay. And then equal. You see, my kids, I will tell him please generate equation like that. Okay, generate equation, generating a quiz. Ops, we cannot. Okay, we cannot. Okay, we'll just simplify this, make factorization or something like that. Okay, we will not do this. So, this is Mr. Watts video. Now we'll come here and we'll make mathways solver. Mathways solver. Okay, I am algebra problem solver. Come to your item. Right. And solve this. Whoops! Look up. X plus 1 equals 0. Solve, please. Yes, solve. Oh, great. X equal minus 1. Good man. Good man. Come now. Okay, no need to listen. Okay. Means that he just solving it. Take this. What is that? Okay, comes that. Enter. Of course. What you will see. We have X equal. Ah, بعدين nothing. Just curves for me. Did nothing. There is no, not the answer you are looking. I will tell him solve, solve, solve. What is my? I will tell him solve, solve. I will tell him solve. Not for the graph. Not for the graph. We need a solution. So he can do. Okay, ChatGPT. Go to ChatGPT. ChatGPT. Okay, solve this. Now, solve this, please. Otherwise, like that. Enter. We provide formula after that. Okay, we just find x equals 0 from x root class. Using sample solver, okay. So, so thank you for listening. I will stop streaming now. Okay. So we will connect the people. Okay. Now we'll stop sharing. Okay, thank you for listening and see you next time. See you again by amazing methods. Thank you and goodbye. Okay. Sorry for bothering you with this video. Well, that's a kind of video.